Hello, this is me, Panda, and welcome back to Andrew's channel. You might wonder where Andrew is. For 4 days, he's traveling around Ontario and Quebec having a business meeting. So during the days that he's having the business trip, I, Panda, will take over. So let's begin. Let's refresh some of the earlier concepts that will come in handy as we dig deeper into transformation. Then we'll look ahead to how the idea would help us with transformation properties. Finding missing angle measurements in triangles. Practice problem 1. Find the value of x in the triangle shown below. Okay, we know that all of the angles of a triangle must add up to 180. So 180 minus 20, it might be easy, 160 minus 70 equals 90, minus 4 equals 86. We got it right. Well, just for kicks, I'm a different man from Andrew. I would just explain, but usually Andrew just reads the explain. So as we said, the three angle measures in the triangle add up to 180. So we can write this as an equation. Which is x plus 20 plus 74 equals 180. So we found out the missing angle measure is 86. So for more practice of this, go to find angles in triangles. Where will we use this? When we transform one figure into another using only rigid transformation, the two figures are congruent. We'll congruence along the other concept, like the fact that the angle measures of a triangle sum to 180. We'll find missing measurements. We'll use this skill in the fine measurements using rigid transformation exercise. Finding area and perimeter. Practice. What is the area of the rectangle? Okay, you already know that the area of rectangle and square is base times height. So 7 times 5 equals 45. And we got it right. Just for kids, I'm going to explain the explain. But I might not do it I will do it. So we already know that the area of a rectangle is width times height, and this is 7 centimeters times 5 centimeters, which is 35 square centimeters. That wasn't too bad, is it? Hold on, sorry. Okay, this is the area of the triangle. The area of the triangle is base times height times 1/2. You might think the height is this and the base is this. Nope. But nope. The height is actually the 5 and the base is actually the 2. So 2 times 5 equals 10. And then divided by 2 equals 5. And we got it right. Just for case, I'm going to do this. We can make a parallelogram from the original triangle and rotate it, copy from it like it's rotated. And the original triangle has 1/2 the area of the parallelogram we just made. So, yeah. So, the triangle has an area of 5 square units. Ready for the last one? Oh, yeah. Okay, what's the perimeter of this figure? We see there's 2 5s being added together. So it's 2 plus 5 equals 10 plus, there's 3 4s right over here, is 3 times 4 equals 12. So the answer is 22. Add them together and the answer is 22. And we got it right. Just for more kicks, let me explain this. The distance around the closed figure is called the perimeter. So we have to add up all sides of this figure in order to get the parallelogram. So the perimeter is 22 centimeters. For more practice goes to represent rectangle measurements, areas of triangles, find perimeter with given side lengths. Where will we use this? Widget transformations preserve length, so we can use the measurements in a congruent figure to help us calculate the perimeter of the area of another figure. We'll use the skills in fine measures using widget transformations exercise. Using angle measures for transversal practice. Below are two parallel lines of the fur line intersecting them. Label each angle with its angle measure. You may use each label as many or as few times as needed. So we already know that this is 109 and so this is 109, and since we have two 109s, it's 71 and 71. And then we know they're perpendicular, so we'll add in 109, 109. That leaves way for the 71 and another 71 to the right. And we got it right. Just for kicks, I'm gonna explain again. So so vertical angles are congruent. So the given triangle and angle F are vertical angles. So like MF equals 109. So okay, we already solved this in this. A linear formula plan has measures that sum up to 180. So the given angle E form a linear pair. So ME equals 71. And this is perpendicular. And this is perpendicular to the. So the same thing happens to both of these sides because they are parallel. Where will we use this? Widget transformations preserve angle measure, the properties of angle measures on transversal will help us make sense of why translations and dilations take lines to parallel lines, but rotations and reflections usually don't. Here are a couple of exercises that build up of angle measures with transversals. Widget transformation preserve properties, dilations, and properties. Okay, thank you for watching Andrew's channel. Don't forget to smash that subscribe button, ring that notification bell, and hit that like button. As always, thank you for watching Andrew's videos, and I will see ya the next day.